For this last video, we're going to be looking at utilizing that second theorem that we talked about in an earlier video. And just as a refresher, that second theorem told us that tangent segments from a common external point, so some point outside of the circle, and the segments that are tangent to the circle are congruent. So looking at number 1, I see that RS is tangent to circle C, and RT is tangent to circle C. Now I want to find the value of x. Now since both of these segments are tangent to the circle C, we learned from that second theorem that means that these two sides are in fact congruent. So that means that RS is equal to RT. Well, RS is 28, so I have 28 is equal to 3x plus 4. And now I can solve for x from here. So subtract 4 from both sides. And I get that 24 is equal to 3x. And then divide both sides by 3. And I get that x is equal to 8. Okay, looking at number 2, it says that points M and N are points of tangency. Find the values of x. So this one's said it a little bit differently. It says that M and N are points of tangency. So it's really saying that this line right here is tangent to circle P and this line with N. And so we know from our second theorem that means that these two segments are congruent. So that means that x squared is equal to 9. And then I can take the square root of that. And here we need to be careful. So I'm actually going to get two different answers here. So that's why it says value or values here. First, I know the square root of 9 is 3, so I have x is equal to 3. But anytime you take the square root, you also get the negative of that. So that means that x can be 3 or negative 3 in this answer. And the reason why is that negative 3 squared, I'm going to write this down here, negative 3 squared is the same thing as negative 3 times negative 3, which is equal to 9. And so that means the square root of 9 can also be negative 3.